In the history of commercial aviation, few aircraft have been as simultaneously capable and disappointing as the McDonnell Douglas MD-11. It was an aircraft that looked magnificent, performed admirably in many respects, and yet somehow managed to fall short of the promises that launched it. The MD-11 represents a fascinating case study in aircraft development, a story of ambition constrained by reality, of engineering compromises that seemed reasonable on paper but proved problematic in practice, and ultimately, of an aircraft that found success only after its manufacturer admitted it had failed to deliver what airlines had been promised. To understand the MD-11, we need to start with its predecessor, the DC-10. By the mid-1980s, the DC-10 had largely overcome the safety concerns that plagued its early years and had established itself as a reliable, capable wide-body trijet. Airlines appreciated its combination of capacity, range, and operating economics. But the DC-10 was a 1970s design, and by the late 1980s, it was showing its age. Fuel efficiency standards had improved dramatically. Cockpit technology had advanced from analog instruments to digital glass cockpits. Aerodynamic understanding had progressed. McDonnell Douglas recognized that the DC-10 needed a successor, but the company faced a fundamental problem. They didn't have the resources to develop an entirely new aircraft. The solution was to create what the industry calls a derivative aircraft, taking the basic DC-10 design and updating it with new technology, improved aerodynamics, and modern systems. This approach promised to be far less expensive than designing an all-new aircraft, and it would allow McDonnell Douglas to leverage the DC-10's proven fundamentals while addressing its shortcomings. The result was the MD-11, launched in 1986 with ambitious performance targets that would prove to be its downfall. The MD-11 retained the DC-10's basic trijet configuration, 2 engines mounted under the wings, and a 3rd engine integrated into the tail. This arrangement had both advantages and disadvantages. The trijet configuration provided redundancy and allowed the aircraft to operate on routes where twins weren't yet certified under ETOPS regulations. However, it also meant higher maintenance costs and fuel consumption compared to more modern twin-engine designs. McDonnell Douglas was betting that the performance improvements they were promising would outweigh these inherent disadvantages. Visually, the MD-11 could be distinguished from the DC-10 by several key features. The fuselage was stretched, with the standard MD-11 being about 18 feet longer than the DC-10-30, allowing it to carry up to 298 passengers in a typical 3-class configuration or up to 410 in high-density layouts. More distinctively, the MD-11 featured winglets, those upward-swept extensions at the wingtips designed to reduce drag by managing the airflow at the wing's edge. The MD-11 also had a smaller horizontal stabilizer and additional fuel tanks, which together were supposed to deliver significant range improvements. The wing itself received substantial attention. While it retained the DC-10's basic planform, it was redesigned with improved aerodynamics, incorporating advanced airfoil sections and refined high-lift devices. The goal was to improve fuel efficiency and increase range while maintaining good low-speed handling characteristics. The wing also featured trailing-edge fuel tanks, an innovative solution to increase fuel capacity without dramatically changing the wing structure. Inside, the MD-11 was thoroughly modern for its time. The cockpit featured a 2-crew glass cockpit configuration with 6 large CRT displays that presented flight information, navigation data, and system status. This was a significant advance over the DC-10's 3-person cockpit with analog instruments. The flight management system was state-of-the-art, and the MD-11 incorporated a sophisticated autopilot system with an innovative feature called performance management, designed to automatically optimize the aircraft's speed and altitude profile for maximum fuel efficiency. The engines were another key upgrade. The MD-11 was offered with 3 engine options: the General Electric CF6-80C2, the Pratt & Whitney PW4460, or the Pratt & Whitney PW4462. These were significantly more powerful and more efficient than the engines that powered the DC-10, with thrust ratings ranging from 60,000 to 62,000 pounds per engine. This additional power, combined with the aerodynamic improvements, was supposed to deliver the impressive performance numbers McDonnell Douglas was promising, and those promises were substantial. McDonnell Douglas told airlines that the MD-11 would have a range of up to 8,000 nautical miles, fuel consumption that was 17% better than the DC-1030, and operating costs that would make it competitive with the newest twin-engine aircraft. These numbers were crucial because the MD-11 was competing not just against aging DC-10s and LC-1011s, but against Boeing 747-400 and, increasingly, against new twin-engine widebodies like the Boeing 767 and the upcoming 777. If the MD-11 could deliver on these promises, it would fill a valuable niche in the market. Airlines found these promises attractive. The MD-11 received a respectable number of orders, with launch customers including American Airlines, Delta Airlines, and several major international carriers. The aircraft first flew in January 1990 and entered service with Finnair in December of that year. And almost immediately, problems became apparent. The MD-11 was not meeting its promised performance specifications. The aircraft's range fell short of the guaranteed figures by a significant margin, in some cases by 300 to 400 nautical miles. The fuel consumption, while better than the DC-10, wasn't meeting the promised improvement. For airlines that had ordered the aircraft based on specific route planning, this was a serious problem. Routes that were supposed to be viable with the MD-11 suddenly required technical stops for refueling, destroying the economics of those operations. The weight of the aircraft was part of the problem. The MD-11 came in heavier than its design target, and in aviation, every pound of excess weight directly translates to reduced performance and increased fuel consumption. McDonnell Douglas implemented numerous weight reduction programs, removing equipment, using lighter materials, and redesigning components, but they couldn't fully overcome the shortfall. The aerodynamics also weren't delivering as expected. Wind tunnel testing and computer modeling are sophisticated tools, but they're not perfect predictors of real-world performance. The MD-11's actual aerodynamic efficiency in flight proved to be less than projected. The winglets, while beneficial, didn't provide quite the drag reduction that had been anticipated. The smaller horizontal stabilizer, intended to reduce weight and drag, created handling characteristics that some pilots found challenging, particularly during landing. This handling issue became particularly notable. The MD-11 gained a reputation among pilots for being difficult to land smoothly. The flight control system, while sophisticated, had certain characteristics that could catch pilots off guard. The aircraft had a tendency to float during landing, and the pitch control during the final stages of approach required careful management. There were numerous incidents of hard landings, and while most were minor, they contributed to the aircraft's reputation and raised insurance costs. McDonnell Douglas's response to these issues was commendable from a customer service standpoint, but damaging from a business perspective. The company acknowledged that the aircraft wasn't meeting its guaranteed performance specifications and offered airlines compensation packages that included performance improvement modifications, financial adjustments, and, in some cases, allowing airlines to cancel orders without penalty. Some airlines did exactly that, converting their MD-11 orders to Boeing aircraft. The company also implemented a series of performance improvement packages, or PIPs, which included aerodynamic refinements, weight reductions, and software updates. These improvements helped, and later production MD-11s came much closer to the originally promised specifications. But the damage to the aircraft's reputation had been done. Airlines became wary of the MD-11, and new orders slowed to a trickle. Meanwhile, the competitive environment was changing rapidly in ways that disadvantaged the MD-11. ETOPS regulations were being liberalized, allowing twin-engine aircraft to fly routes that previously required 3 or 4 engines. The Boeing 777, which entered service in 1995, offered similar capacity to the MD-11 with just 2 engines, meaning lower maintenance costs and better fuel efficiency. The 777 was also designed from the ground up as a modern aircraft, without the constraints of deriving from an earlier design. It quickly became the aircraft that the MD-11 was supposed to be, a long-range, efficient wide-body that airlines actually wanted. In the passenger market, the MD-11 struggled. Airlines found that while the aircraft was capable, it wasn't economically competitive with the alternatives. The 3-engine configuration, which had been an advantage in the era before widespread ETOPS certification, was now a liability. Every route the MD-11 flew, it was competing against twins that could do the same job with lower operating costs. American Airlines retired its MD-11 fleet after just a few years of service. Other passenger operators followed suit. But here's where the story takes an interesting turn. While the MD-11 was failing in passenger service, it was finding remarkable success as a freighter. The cargo market has different economics than passenger service. Cargo operators prioritize payload capacity, reliability, and acquisition cost over the last few percentage points of fuel efficiency. The MD-11's large cargo capacity, its ability to carry heavy loads, and its robust airframe made it attractive to freight operators. FedEx became the MD-11's savior, ordering the MD-11F freighter variant in substantial numbers. UPS followed suit. These cargo operators appreciated the aircraft's capacity and found that its economics worked for their business model. The MD-11F could carry up to 200,000 pounds of cargo, making it one of the most capable freighters available. Its range, while disappointing for passenger operations, was adequate for most cargo routes, and crucially, cargo operators could acquire MD-11s, both new-build freighters and converted passenger aircraft, at prices that made the economics viable. McDonnell Douglas also developed the MD-11ER, an extended range variant that addressed some of the range shortfalls, though it came too late to revive passenger interest. When Boeing acquired McDonnell Douglas in 1997, the MD-11's fate was sealed. Boeing had no interest in competing against its own 777, and MD-11 production ended in 2000 after just 200 aircraft had been built, a disappointing total compared to the hundreds of orders McDonnell Douglas had once hoped for. Yet the MD-11 story didn't end with the end of production. Those cargo operators who had embraced the aircraft continued to operate it, and continue to do so today. FedEx operates a fleet of over 50 MD-11s, and they're expected to remain in service for years to come. UPS, Western Global Airlines, and other cargo operators have also maintained their fleets. The passenger-to-freighter conversion market for MD-11s has been robust, with numerous aircraft being converted from passenger configuration to cargo use, extending the type's operational life. In cargo service, the MD-11 has proven to be reliable and capable. The very characteristics that disadvantaged it in passenger service, its fuel consumption and maintenance requirements, matter less in the cargo world where different economic factors prevail. The aircraft's reputation has been rehabilitated in this segment, though few remember that it was once intended primarily as a passenger aircraft. From a technical perspective, the MD-11 is a competent aircraft. It incorporated genuine innovations, particularly in its flight management and automation systems. The performance improvement packages did address many of the early shortcomings. Pilots who fly the aircraft regularly generally speak positively about its capabilities once they master its particular handling characteristics. The aircraft is not inherently flawed. It simply promised more than it could deliver and arrived at a moment when the market was moving decisively toward twin-engine aircraft. The MD-11's failure in the passenger market had broader implications for McDonnell Douglas as a company. The substantial financial commitments required to compensate airlines for the performance shortfalls, combined with slow sales, damaged the company's financial position. The MD-11 was supposed to be the aircraft that would carry McDonnell Douglas into the future of wide-body aviation. Instead, it became another factor in the company's eventual absorption by Boeing. There are lessons in the MD-11 story that resonate beyond this particular aircraft. One is about the limitations of derivative designs. By basing the MD-11 on the DC-10, McDonnell Douglas saved development costs, but also inherited constraints that limited how much they could improve the design. The trijet configuration, in particular, was an unchangeable legacy that became increasingly problematic as the industry evolved. Another lesson concerns the danger of over-promising. Had McDonnell Douglas been more conservative in their performance guarantees, the MD-11 might have been received more favorably. The aircraft's actual performance, while not spectacular, was respectable, but measured against the promises that had been made, it was a disappointment. In the aviation industry, credibility matters enormously, and once lost, it's difficult to regain. The MD-11 also illustrates how quickly market conditions can change. The aircraft was conceived in an era when ETOPS restrictions limited where twins could fly, and when the 777 was still on the drawing board. By the time the MD-11 entered service, all of these factors were changing rapidly. An aircraft that might have been competitive in the mid-1980s was struggling by the early 1990s, not because the aircraft itself had changed, but because the world around it had. The MD-11 was also the last wide-body trijet developed, marking the end of a configuration that had dominated long-range aviation for decades. It was the last commercial aircraft to bear the McDonnell Douglas name as an independent company, and it was, in many ways, the last attempt to compete with Boeing in the large commercial aircraft market by an American company. Today, the MD-11 occupies an interesting place in aviation history. It's neither celebrated like some classic aircraft, nor completely dismissed as a failure. It's an aircraft that promised too much, delivered less than expected, yet found a second life where its particular combination of capabilities and economics made sense. The sight of an MD-11 in FedEx or UPS colors, climbing out of Memphis or Louisville with a full load of cargo, is a reminder that success in aviation can take unexpected forms. The legacy of the MD-11 is complex and somewhat melancholy. It deserved better than it got, but it also promised more than it could deliver. It remains in service today, performing valuable work in the cargo world, a reminder that aircraft, like people, sometimes find their true calling in unexpected places. The MD-11 stands as a testament to the unforgiving nature of commercial aviation, where even capable aircraft can fail if they don't meet the exact needs of the market at the exact right moment.